Hello again. So here's the third and last installment for 3.1a, which is application basics. So for time, I wrote the problem down, so let's read through it. A new housing community digs a lake. They stock the lake with fish, but a disease strikes and the number of fish decreases as weeks pass at a constant rate. At 12 weeks, the lake has 5,560 fish. At 20 weeks, the lake has 3,000 fish. Find a function to model the number of fish in the lake, F, after W weeks. Before we do anything, we should be talking about input, output. Okay, I hope you guys are taking my advice for that. So let's think about, in this situation, what has to happen first. Okay, what am I going to count on? It's going to go on no matter what. And then what depends on that? Well, the weeks are going to go by, right? So the input here is going to be W, which is weeks. And what am I trying to measure? Remember, output is always what you're trying to get as an answer or as a result. I'm trying to measure the number of fish. Okay, so that's F. Now, let's talk about what you need to do to get to this answer, because I can't just jump in from the information in this problem. There's some information that I'm going to need to figure out. First of all, I want to note what direction this is going. The fish are dying, okay? The number of fish decreases. How are they decreasing? They're decreasing at a constant rate. That tells me that it's the same number of fish dying every week, okay? That sounds very linear, okay? Same number of fish are dying, constant rate, okay? That's what that means. So these two things are clues that I'm talking about a linear relationship. What's this information? At 12 weeks, the lake has 5,560 fish. At 20 weeks, the lake has 3,000 fish. Weeks and fish. Input, output. That sounds like two ordered pairs. So I know that after 12 weeks, 5,560 fish, that's an ordered pair, 12 comma 5,560. And I know 20 weeks and 3,000 fish. It's another ordered pair. What do I need in order to create a linear function? Same two questions. Do I have slope? Not yet, but can I find slope? Sure I can. I have enough information here. This could be an x1, y1. This could be an x2, y2. So I'm going to use point slope form. Y equals m times x minus x1 plus y1. Okay? However, well, I don't need this yet, so let's hold on to this. I need slope first, okay, in order to use this, because neither of these is my y-intercept. Okay, I jumped ahead a little bit. I'm sorry about that. Let's go back. I need to figure out my rate of change. How do I figure out rate of change? Slope is the change in output over the change in input. Okay? So in this case, it's going to be 3,000 minus 5,560 over 20 minus 12. I'm losing 2,560 fish over 8 weeks, okay? How do I know those are the units? Because what are my units on Y, okay? These are fish. What are the units on, it's not really Y, okay? It's just output here, F. So that's going to be fish. My input here is going to be weeks. So fish per week, okay? Makes sense in the problem. So I can either keep this as a fraction, or I could simplify this. It winds up being negative 320, okay? But again, units are fish per week. So I'm losing 320 fish per week or each week. Okay? Now I can jump in, and because I don't know the y-intercept, I can jump in and plug in an x1, y1. So this will be y equals negative 320 times x minus, I'll just use the first one, 12 plus 5560. All they asked for was find a function. They didn't say what kind of model it had to be. So this is a function. My problem, though, is that I need to get away from x and y. Got to get back to the units, to the variables they were using. So f equals negative 320 w minus 12 plus 5560. And now I have my weeks and my fish. Okay? If they asked you a follow-up question, okay, how many fish did they start with in the lake? How would you answer that? Okay, so follow-up question. How many fish did they start with? Okay, start. Start means time equals 0, or in this case, weeks equals 0. No weeks went by. Okay, that means I'm looking for my y-intercept. I can do one of two things. I could either physically plug 0 in here and work it out, or I could just simplify this by distributing the 320, negative 320, and then combining like terms. So f equals negative 320w plus, you could take out your calculator for this part. So 320 times 12, 3,840 plus 5560. Then add those together, and I get f equals negative 320w plus 9,400. Now I know that 9,400 is my b value. So the ordered pair for that will be 0, 9,400. And then I can say that they started with 9,400 fish. Okay, so that's an example of a real life situation using point slope form. Okay, and I want to do one more. Just to give you a well-rounded problem. So the last one I want to do is, I just lost the one I wanted. Oh, here we go. A store owner prices an item at $150 when he first stocks it. So he first puts it out, it costs $150 in his store. Every week that the item doesn't sell, he lowers the price by 3%. Find a function to model the price of the item, P, in dollars after X weeks. Okay. This sounds like a constant percentage. Every week, the item doesn't sell. He lowers the price by 3%. All right. That sounds like it's going to be an exponential, right? But before I jump into all that, I'm going to decide what makes sense for my input and output in this situation. Okay? Weeks are going to go by that he doesn't sell this item. So the input is going to be X, which is weeks. What am I trying to measure here? I want to know what he's going to sell the item for. So that's going to be the P, which is the price of the item in dollars. Okay? Now we can talk about, this looks very exponential because I have a percent rate. Okay, a constant percent rate. I guess I should be really clear. I have a constant percent rate. So that tells me that this is going to be exponential. Okay, so we have an exponential function with a rate of 3%. Decreasing, a 3% decrease. So the rate is really negative 3%. He's lowering the price by 3%. First thing I do is I think about the original price being 100%. If I lose 3%, that means I'm only going to get 97% of the original price each time. Okay? This is the percent that I'm keeping. I can't work with that. I have to work with the decimal. So the factor is 0.97. Okay? In the description, does it sound like I have a y-intercept? The store owner prices an item at $150 when he first stocks it. Anything that happens at the beginning of the set time, that's your time zero. So that's your y-intercept. So yeah, I have the y-intercept. I know that the y-intercept is 0, 150. So now put this all together. The price of the item X weeks later will be 150 times 0.97 raised to the X, however many weeks. Then I could use this to figure out how much it's going to be 1 week later, 2 weeks later, 3 weeks later. I can make a table. If the numbers are what speak to you, you could make a table first and you could physically decrease the price by 3% every time. That's also an option, again, so you can spot the pattern, okay? There's lots of ways around these types of problems. There's not just one approach, which is the great thing, actually, okay? There's lots of ways to get to the correct answer. All right, so you've seen a couple of each type of problem. There's a lot more practice in the book, okay? So please make sure you're practicing. If you have any questions, please don't hesitate to ask, and I will see you in the next video.